Introduction to the Robotic System Hierarchical PetriNet Tool. The developed Robotic System Hierarchical PetriNet Tool can be utilized to specify the robotic system activities. The activities of the robotic system are specified utilizing 5-layered hierarchical PetriNet. The first layer is the multi-agent robotic system layer. It defines a single net representing the activities of each agent by individual pages. Another layer is an agent layer, which describes the activities of each subsystem existing in agent. The third layer is the subsystem layer, which describes the activities of subsystems switching between behaviors. Each behavior is defined within the behavior layer. The behavior layer defines how the subsystem executes the transition function and how it sends and receives data to from associated subsystems. The last layer is the action layer, which defines transition function and communication models. For each layer, it is also possible to define the additional data associated with the robotic system structure. The Robotic System Hierarchical PetriNet tool contains two modules enabling automatic generation of the robot controller code. The former module generates C++ code that interprets the defined hierarchical PetriNet, while the latter automatically generates from hierarchical PetriNet C++ code and all necessary files for Robot Operating System (ROS). To show how the tool can be used, a rudimentary experiment was presented. A controller for a manipulator having 7 degrees of freedom, utilizing impedance control, was designed. The task was to move the end-effector along a circular trajectory. The automatically generated robot controller for the manipulator was run using Gazebo simulator. Within this experiment, the control subsystem communicates with virtual effector using ROS topics, while the virtual effector communicates with Gazebo utilizing shared memory libraries. The subsequent positions of the end effector were saved to the file, and the plots were reproduced by the MATLAB program.